Can people see the slides? I can't see them on my screen, but I can see them on the screen behind me.
Yep.
All right, brilliant.
Okay, yeah, we'll make a start then. So good afternoon, everyone who's joined online. My name is Les Fox and I'm the chairperson for the Cheshire and North Wales section of the PWI. We're here in sunny Crewe today in the YMCA. So there's a few of us here and there's those people who've joined online. So thanks very much to everyone who has shown interest and joined for our April meeting. Just before we start today's presentation, I've just got a couple of announcements for upcoming future meetings. So 1st of May, we've got a talk by Hayley Porkis from Atkins. He's a principal engineer and he's going to talk to us about modelling using the Vampire software. So I have seen that talk before in Atkins and it's a really interesting talk. So for those who have heard of Vampire software but don't know much more about it, which is where I was before I sat and listened to that talk, it is really worthwhile listening to that one. And then the 5th of June, we've got Brian Weedin and Chris Metcalf-Smith from Greenfix, and they're going to talk to us about track and slope stabilisation systems. And yeah, so that's our programme up to the summer recess. And this afternoon, we've got Rob Cummings from Northern Rail. So Rob is the Seasonal Performance and Improvement Manager at Northern Rail, and he's going to give us a talk on managing train operations in extreme weather. So I'll hand you over to Rob.
Thanks, Les. Good afternoon, everybody. I'll just stick my camera on, shall I? Right, so yes, I'm Rob Cummings. I'm the Seasonal Performance Improvement Manager for Northern Trains. I've been doing the role for 10 years now. And before that, I was 16 years with Network Rail. Some of that time was spent doing seasonal stuff, mostly around autumn. My role primarily is looking at autumn, but obviously, certainly over the last 10 years, we've seen more intense weather events, which means we are looking at other things as well now. Right, let's see if we can get this slide to move on. Just bear with us a sec. First technical problem of the day. Oh, sorry, are the slides on the screen moving?
It did move, then move back.
We're back to the start now?
Yeah.
Right. I can't see it on my screen. Just bear with us a sec. It seems to be flipping over.
Sometimes I use the, is that what you use?
Well, it seems to be moving online up and down, but not on anything we've got visibility of. Just hang on. Why is that? It's not that one. Yeah, let's try it. I'll stop sharing and then share again, see if that solves the problem. Interestingly, it's not. Of course, it won't have done, will it? Ah, here we go. Right. There we go. I presume everybody can see the slides now. So yes, just got some graphs, just showing you the changes. Obviously, we see big peaks and troughs in conditions, but things like flooding, the peaks are getting higher. Interestingly, the heat speeds, we had that peak in 2020, 2019, 2020, which was actually more impactful than the record temperatures we had in 2022, which is actually more of a function of the fact that we stopped running quite a few trains during that really hot spell. And this was partly because we weren't really sure what the railway could cope with above 35 degrees. We've done quite a lot of work on that in the last couple of years, and we'll talk about that later. And then, as we've seen in recent events, Storm Eowyn, particularly in January, a big increase in the impact on high winds. What we're also seeing is quite a big increase in landslips, and some of them are very disruptive. So Baildon, which is on the route between Bradford Foster Square and Ilkley, there was a landslip there in February 2024 that closed the line for 6 months. It's actually required the evacuation of some residents from adjacent houses, and those houses were subsequently demolished. But you look at it from the passenger perspective, we carry an awful lot of students from Baildon into Bradford in the morning, so that was a long time to organise replacement transport for them. Also in February 2024, we Workington Bridge 37, Derwent Viaducts closed to rail traffic for a few weeks, and that was due to scour affecting the piers. We then had another landslip in March 2024 for a couple of weeks in West Yorkshire around Pontefract Tanshelf or between Pontefract Tanshelf and Nottingley, and then Haigh Bar, which emerged not long after. This is between New Mills and Strines. We had to introduce single line working for several weeks, and then there was a six-week blockade through the summer holidays. That cost £13 million to sort out for Network Rail. And interestingly, there's another speed just gone on pretty well adjacent to that site. So fingers crossed, we're hoping that doesn't become as big as the Haigh Bar landslip. But those incidents are highly disruptive for us. Oops, what happened then? Right, so climate change. We're confident that in the coming years, we're going to see warmer but wetter winters and drier, hotter summers. And we're going to see more intense precipitation levels, as we've seen already, but more potentially. And we're going to see higher mean sea levels, which influences tides and surge and depth-limited waves. And for northern, particularly the Cumbrian coast, it's an area that's particularly vulnerable to high sea levels and water overtopping the seawall onto the railway. Slightly less confidence in winds and storms. And though we haven't mentioned snow and ice, the chances are that we will continue to see those events, but not at the same frequency we might have done in the past. This is some Network Rail figures on the impact of extreme weather events. So you can see the green, the wind is the highest impact, blue, flooding. So it's similar to the graphs we showed earlier. Weather forecasting. Down the years, weather forecasting has improved due to advances in computer technology. They reckon it's improved by a decade since the middle of the 20th century as supercomputers have increased and the computing powers improved. We've usually got a reasonable amount of certainty a week out of what events are going to happen. We also get long-range forecasts, which actually go 3 months ahead, but obviously the confidence in those can vary. Interestingly, the latest long-range forecast, we've got low confidence about. We've actually got more confidence in June being quite sunny than we have in May, which could apparently 60% chance of being unsettled, 40% chance of being sunny. So it'd be interesting to see when May comes around how that pans out. There are some new tools available as well to Network Rail, which helps us as operators manage extreme weather. So the convective rainfall tool came in 2 or 3 years ago, and that uses radar data to monitor 5 kilometre squares on a map. And if it triggers, we can put a 40 mile an hour speed on using GSMR. Now, this is quite useful in that it actually just targets the area where the convective rain, because obviously convective rainfall is a very high rate of rainfall in a short period of time. It comes, it dumps, and it goes again. So what we've had to do in the past was have quite widespread 50-mile-an-hour blanket speed restrictions. So what convective rainfall does is reduces the area of those restrictions, but also reduces the time they're imposed, which reduces the impact on train operations. There's also a system now called Gusto that Network Rail North West are trialling on the west coast, north of Lancaster, which allows you to implement speed restrictions based on wind speeds. Again, much more localised and for shorter time periods than we've managed in the past. However, we're not able to predict every weather event, and the South Cumbria December 2023 was one of those events that caught us out. So basically what we had on that day was a Saturday, the 2nd of December, sorry, I can't read my own slides. We had two bands of snowy weather converging in the Irish Sea. The meteorologist actually blamed the Isle of Man for pushing these two weather fronts together. And as a result, we had a massive dump of snow in excess of 20 centimetres. It reached 30 centimetres across some areas, and this was across South Cumbria, in areas where, while you expect it on the higher ground in Cumbria, around the coast, in the Barrow, Ulverston, Carnforth area, it wouldn't normally have been expected. Now, the original forecast was for between 2 and 5 centimetres of snow. The Met Office declared an amber weather warning about late morning, and it was shortly after when it all fell down. Now, there was a big impact. It wasn't just on the railway. There was power loss to 7,000 homes, 200 cars trapped overnight. There's a lot of people stuck in Windermere because of the weather. Now, we had a train that got stuck at Ulverston after the snow brought trees down, both in advance and in the rear of the train. So it got to Ulverston, it set off towards Barrow, realised there was trees blocking the track, tried to return, but in the meantime, some more trees had fallen down behind it. There were 70 passengers trapped on board, and this was quite late on a Saturday night. They were trapped for a number of hours before a Network Rail 4x4 managed to make it through, and he actually acts as a bit of a taxi, shuttling people from there up to Barrow. They moved about 35 people. The other 35 just made their own way in the end. But they also finished up having to buy a load of snacks and drinks from a service station. So what we've done now, both ourselves and Network Rail have on-call vehicles we put foil blankets and water and snacks on board at this time of year, just in case we get that kind of event again. And that's a picture from Ulverston of the night of the 2nd of December. We get a 5-day forecast from MetDesk, who provide Network Rail with the weather forecasting, and this is an example. There are 14 weather areas across the Northern Trains network, and obviously considerably more across the rest of the country. Cumbria is one weather area, Lancashire's another, and then we have Central West, which kind of covers South Lancashire and Merseyside, and Central East is the routes radiating around Manchester. So you can get the various alerts for different events. Obviously, there you've got wind, heavy rain, snow, frost. So we've got these 4 levels: normal, aware, adverse, and extreme. So extreme and adverse will normally trigger a phone conference, an extreme weather action team conference, or EWAT, which are chaired by Network Rail, but the operators come on them as well, and we discuss what the forecast is, what mitigations are in place, potentially discuss any service withdrawals or amendments ahead of the incident. These are the alert thresholds for different types of weather. Obviously, we won't go through them, there's quite detailed, but that's what we kind of use to activate the different levels. So, as I mentioned, the EWATs are led by Network Rail route controls. It's interesting, some routes have separate internal and external EWATs. So in the northwest, they actually have a combined EWAT with maintenance and the train operators and the Network Rail operations. Whereas on the eastern region, they actually have a separate internal one. But Eastern region covers basically from King's Cross to the Scottish border, so it's a much bigger area, and to actually combine it would be quite unwieldy. So I can understand the logic behind it. So yeah, as I mentioned, it's attended by asset managers, maintenance operations, and the train and freight operating companies. So we look at any line of route restrictions and blanket emergency speed restrictions. Have any plans for route proving? So after the event, can we run a loco down there just to make sure it's completely clear before we start running passenger trains again? Trash screens and culverts for blockages, checking them so we don't get flooding. Any additional resources we can bring in, chainsaw gangs particularly, with high winds, do you want the extra OLE resource? And also to ensure we're consistent, we agree that the customer messaging so that we're not putting out contradicting messages to what other operators might be putting out. So we'll turn to hot weather. So historically, the UK network was designed to operate up to 35 degrees centigrade. So what we saw in July and August 22 was air temperatures that were significantly higher. 38 was recorded locally. It just got above 40. I think there's an RAF base in Cummings, in Lincolnshire, recorded just over 40 degrees. But yeah, there was a lot of uncertainty because we just didn't know how the railway would react above 35 degrees. And Network Rail on the eastern region actually stopped the east coast, south of York, for a 24-hour period at the peak of it. But since then, we've done quite a lot of work. Network Rail have done quite a lot of work to understand how temperatures can affect the infrastructure, and we've developed key route strategies. So this is basically, the routes we try and keep open, or the services will run on them. So at the moment, we've got 3 levels. There's one route-specific level for the Hadfield line, which we'll come to in a bit, that's particularly vulnerable to hot weather. That's around about 36 degrees. At 38 degrees, there'll be a 45/90 differential speed on OLE on electrified routes. So that's 45 for freight, 90 for passengers. And then if it gets to 41, and obviously we've not reached 41 yet, but we're planning for potential future temperatures. This is when we'll look at thinning out train services and not running on some lines of route. So that's the key route strategies. So yeah, as I said, they set out the service that allows to operate within the limits of the infrastructure. The key air temperature is 41 degrees, as I've mentioned. There's other locations where track might be at higher risk, and again, we'll pick that up on another slide, but they're critical rail temperatures that appear on a register every week that might need a 20-mile-an-hour emergency speed restriction applying if a certain temperature is reached. And bear in mind, rail temperatures tend to be 1.5, roughly the rule of thumb is 1.5 times higher than the air temperature. So yes, the Hadfield line, the bane of my life. The route was originally electrified in the 1940s. In fact, they actually started in the late 30s, but then obviously it got suspended during World War II and was finished in the late 40s. The original electrification was 1500 volts DC, so you got a higher current but lower voltage than modern 25,000 volt AC OLE. So the clearances were less between the overheads and any structures were far less than modern standards. So after the closure of the route to Sheffield, the Hadfield line was converted to 25,000 volts AC, but with the same OLE equipment and the same clearances. So clearances are substandard, and there's also no tensioning system to maintain the correct tension in the OLE. So in the 1960s and 70s OLE installations, you know, at the end of every cable run, there's a pulley system, and the weights keep the tension in the system as it expands. The more modern installations, you know, on Manchester Blackpool, for instance, it looks like one of these giant, you know, the washing line, the extending washing lines. It's that kind of arrangement for maintaining tension, but there's nothing on the Hadfield line. So basically, when the air temperature reaches 36 degrees, the OLE will sag to the point where we have to take the electric units off and substitute them with diesels. There is a possible solution. There was a similar, I lifted this article out of Modern Railways a couple of years ago, and that paragraph describes a problem on a route out of Liverpool Street in London to Chelmsford that's almost exactly the same issues that were with the Hadfield line. So I think it took 15 years to put a tensioning system in. Clearly, they've got a much improved service on that. So, yeah, that's the question. Could that be implemented on the Hadfield line any time soon? So, KRS questions, something we're still kind of discussing this with Network Rail. Given the big regional temperature variance across Britain, where would a KRS be applied if it were triggered? So, looking at Eastern region, if it was 41 degrees at King's Cross, would we apply the KRS in Newcastle? You know, you'd like to think we could regionally take into account regional variations, but also you've got to think of the LNER driver who's driving from King's Cross to Edinburgh potentially, or even Aberdeen and Inverness, and you don't want him to be having multiple blanket speed restrictions on his journey north. So there's a bit of a compromise to be found with those. Industry can't cope with short-term timetable changes at the moment. Anything under 5 days can't be picked up by systems, so all the changes have to be implemented manually by the train operator and Network Rail controls. Clearly, there's an opportunity in the future to use technology to improve that. Will passengers take heed of any messaging that we've put out, and routes suffer overcrowding on really hot days? I mean, you know, we've put out not to travel notices in 2022, but advised, you know, against checking before you travel. And obviously, everybody heads to the seaside at Blackpool, Bridlington, and Saltburn. In the Bridlington line, the Hull Scarborough line actually is mostly jointed track, and that had a continuous 20-mile-an-hour CRT on the hottest days in 2022, which actually prevented us running a service through it, which was a shame because that's where everybody wanted to go in the hot weather. And there's also, it's quite complicated with government guidance and things like school term times. You know, a lot of schools will close in adverse weather events, and it's catering for them, where we've got flows of kids going to school, and we certainly don't want to take them in the morning and not be able to bring them back in the evening. That we've got to take into account. So I mentioned critical rail temperature sites earlier. So these are sites that haven't been stressed, have insufficient resistance to buckling, or where the track's been disturbed by tamping, for instance. And they're kept on a CRT register that's sent out weekly from the 1st of April to the 30th of September. So the first one's landed on my inbox this week. There's 3 levels depending on the temperature. So you've got a watchman, and then a differential speed, and then the ultimate, if the critical temperature is reached, it'll be a 20-mile-an-hour CRT. As I mentioned earlier, we had one in 2022 where 53 miles between Hull and Scarborough. It's complicated where you've got an existing speed for another potential reason. And we had an incident in 2023 where a CRT was imposed over an existing ESR, and that resulted in an overspeeding incident. So we've got to get a lot cleverer about how we board and inform drivers about speeds. So train operator measures. What can we do to make the fleet more resilient? Obviously, Northern have got at least 2/3 of the fleet date from the mid-80s, and are getting quite elderly now. That legacy fleet's got a maximum operating air temperature of 38 degrees and are not air conditioned. On the hottest days, it does feel like you're in an hairdryer. Clearly, we can't stop running if those temperatures are exceeded, but by thinning out the service, it gives us resilience to run perhaps multiple units coupled together in hot weather. We also have to contend with dandelion season, which is 2 to 3 weeks every May, where we get loads of airborne seeds flying around, and they basically jam up the radiators, the engine overheats, and we get these what they call return to idle incidents, where the power just drops out until the engine cools down, and then they can start up again. The Buxton line, where you've got quite a steep gradient, particularly vulnerable for these return to idle incidents. And basically all the depots have quite an intense overnight regime of brushing and jet washing radiator grills to clear all the debris from them. It was interesting when we got the 101 CAF trains introduced 4 to 5 years ago. We were told that these trains wouldn't be affected by this, and first summer it turned out they did. And we've had to introduce a regime where we thought we wouldn't have to do that with these trains. If we get any stranded trains in hot weather for whatever reason, there is a process that both Network Rail and the train operator controls use to assess whether an evacuation needs to take place. Obviously, in the hottest weather, those decisions are accelerated, and also we keep bottled water in both our response vehicles and the Network Rail response vehicles to give to passengers that get stuck. At stations, we have to look at crowd control measures if there's any big failure that prevents or that results in a build-up of passengers looking to travel. And you look at places like Euston and Birmingham New Street when there's disruption to the network on any particular reason. It's amazing how quickly passenger numbers build up. Northern Network Rail and some of the other TOCs like Avanti have installed water fountains at many stations now. That means you can refill a water bottle for free. Just helps passenger comfort in hot weather. We also hand out bottles of water at key hubs when it gets particularly hot. You also have to consider staff exposure to hot weather. We hire in air conditioners in mess rooms and offices if it gets particularly hot. In 2022, when we had that really big spike, we did try and limit the amount of time people were out working between breaks to no more than 2 hours. We've also got ill passenger policies. So we've got an app on the phones now that the conductors have. Basically, if you put in if you have somebody is taken ill at a certain station, you put it into the app and it'll tell you, whether you stop and call an ambulance or whether it's easier to keep going to a bigger station where you'll get an ambulance quicker. So if you're obviously in the middle of nowhere, chances are it'll take an ambulance a lot longer to get to you compared with the city centre. The other big thing we discovered in the hot spell in 2022, with the CAF fleet again, new trains, air conditioned. But what we found was if they sit on a platform with the doors open for any length of time, all we're doing is air conditioning the environment. So we just try and keep the doors shut when trains are in platforms, just to give the air conditioning chance to work in the saloon and in the cab. So moving on to convective rainfall, it's usually very intense rainfall. It falls in the summer and is very difficult to predict. It did cause a derailment at Watford Tunnel in 2016. There's a whole load of water from beyond the railway got channeled down the side of a tunnel and caused a landslip. There's a London North Western, or what they call them, I think it was predates London North Western train hit the landslip, derailed, fortunately stayed upright. There was a train coming the other way and they did kind of clash, but it could have been a lot worse if it had derailed and fallen on its side. So I mentioned the convective alert tool, and that uses the weather radar to trigger alerts in real times. So there's 40 mile an hour speed restriction imposed over a limited geographical area. Moving on to flooding. So flooding is covered by module M3 of the rule book. So basically, normal working continues until the flooding reaches the underside of the railhead. If it goes above that, we're down to 5 miles an hour. And then once it goes above the railhead, generally we stop running, although that's the decision for the relative controls. Again, flooding can cause significant disruption to passenger services. It's becoming an increasing problem, particularly when we get lots of flood sites on different routes. It's interesting that much of the water that causes flooding originates from outside the railway, and there is this right to natural drainage. So basically, if water flows naturally on off the surface of land, it's permitted to flow downhill onto your neighbour's land, but you mustn't, if you start channeling it or you change it in any way that causes damage to your neighbour's land, then that's when you fall foul of the law. There have been some instances. There was one at T-Bay on the west coast years ago with a farmer that traditionally ploughed his land parallel to the railway, and then one year decided to do it perpendicular to the railway, which just created a whole load of channels, and it did actually flood the West Coast main line. So it's amazing what instances can cause a minor change can cause a big impact. Also beyond the boundary, so I've got a growing problem. There's an awful lot of developments adjacent to the railway now, and that's creating additional runoff. So a couple of years ago, well, it's probably more now, 3 or 4 years ago, there was a housing estate built at Broughton, just north of Preston, on the West Coast main line. That caused regular flooding. That's now been resolved, but it only got resolved by going through court. Apparently they're tied into the railway drains without permission. There was another instance I remember reading about at St Helens with a housing estate that didn't even have planning permission. And again, no water plan was agreed, and it was actually pumping raw sewage into the railway, which wasn't great. So Network Rail's asset protection departments have got the task of monitoring developments and try and weed out some of these issues at the planning stage. This is a classic one that impacts on Northern, Rotherham Central. This route's actually on the super tram train route as well. So we share it with the super tram. It's adjacent to the canal at Rotherham, which then feeds or is fed by the River Don. Now, I think some of this problem has only emerged over the last few years because in 2015, Sheffield city centre flooded really badly, and some flood prevention measures have been put in, which have potentially moved the problem downstream. So what we get now, when it floods as bad as the pictures, Network Rail go in and remove the ground-based signalling system. So we need about 6 hours. We need to close the route about 6 hours before it starts flooding, just to take all the stuff out of the lopes, and then 6 hours afterwards to put it back in again. There has been this flood prevention scheme been built where the water goes into the canal. The Network Rail contributed 400,000 towards the cost of that. There's a wider flood alleviation scheme proposed for Rotherham, and I believe that's potentially starting later this summer. So hopefully that will give us a bigger benefit. I mean, Rotherham doesn't flood quite as often as it used to do, but it does still flood from time to time. Bridge 96 at Walston on the Calder Valley is another problem area. So it's a flat steel deck over a stream, the level of which rises or fluctuates really quickly. It's in a very steep valley, so water just comes off the hills really quickly. And once it gets to the underside of the structure, the route has to be closed. There's not many options to improve this situation on the railway without a massive cost. One thing that we are looking at, or Network Rail looking at, is there's a disused reservoir up in the hills. They're looking with the EA and United Utilities to reactivate that, so that would collect water and effectively attenuate it, hold it in the hills and not have it running down the level. We've now got CCTV monitoring the river levels, so if it hits a certain level on the CCTV, we will stop trains leaving, so it stops them getting trapped. But it does cut. It's obviously a major route between Manchester and Leeds. We had an incident in 2020, 2022, 23, I think, where we had 3 named storms in a matter of days. And Manchester United were playing away at Leeds on the Sunday. The Diggle line was closed by the Transpennine route upgrade, so it was the only Transpennine route that was open in the morning. We did put warnings out, but clearly if you've spent the best part of £100 on a Premier League football ticket, you're going to take your chances. The railway was shut, flooding. The M62 was also shut, so it wasn't a great day that day. I can't remember what the result was in the game either. But yeah, as I mentioned, the reservoir's a potential solution. High winds, very unpredictable to manage because the damage to do can be quite random and difficult to predict. Usually fallen trees, but we've also had garden sheds and trampolines. Why we don't win more gold medals in the Olympics at trampolining, given the amount of training facilities you see if you go anywhere on a train, virtually every garden seems to have one. Network Rail vegetation standard was changed in 2018 to address the risk of fallen trees. So basically we take a line from the furthest railhead 3 metres into the line side, and then we have to clear everything. That's basically that it's the action zone. No, I'll get it right in a minute. The immediate access zone is the 0 to 3 metres. We then take a line at 45 degrees to the boundary, which is the action zone. And the idea is with that, it takes out any trees with potential to fall down. Clearly in 2018, that was never going to happen overnight, and there's currently a derogation against that being achieved. I forget where we're up to. I think we're into the mid-30s before the derogation runs out. There's also a big issue with third-party trees falling onto the track, which are a little more difficult to control. This incident happened in Scotland a couple of years ago, or 18 months ago, and that was a third-party tree. There's been a recent RAIB report into a tree that fell across the track in Anglia, and a train hit it, and that's calling on Network Rail and third-party landowners to cooperate more on identifying third-party trees that are dangerous, a risk to the railway. Snow and ice. So Northern operate over 460 stations. If there's a forecast of 0.5 degree or less, all those stations where every station basically gets an individual forecast each day, and whereas every station that triggers that 0.5 degree or less, we have a contractor that will visit them between late afternoon and morning, and they'll deposit products called Procoat, which is evaporated seawater with a corrosion inhibitor. It's still, it's done manually. It's like feeding chickens, the way they throw it out. Some do have these dispensers, like a small lawnmower that throw it out, but most of it is done by hand. They also do snow clearance if there's snow on on the platforms, and we do say to them every year, brush snow to the back of the platform, not on the track. What we did see with the snowy weather earlier this year, first week in January, it was very difficult to keep the platforms free of snow because the guys were going out and clearing it while it was still snowing. So 2 or 3 hours later, there was more snow. But because it's such a vast operation, it's difficult. You can't wait until it stops snowing to start doing it. And once it goes hard, it gets even more difficult to remove. If -4 is forecast, we try and run diesel units periodically through the night to stop them freezing up. It's quite a big effort that requires a lot of people to work later or come in earlier on overtime just to make sure that they are. And it's particularly useful at places like Buxton, where we stable a couple of units every night, and it does get particularly cold up there. Electric trains, if we can leave the pan up, so there's current going into them, and leave the heating on. Again, well, we've had an issue there with the Blackpool electrification because it's not electrically separate from the West Coast main line. So the new CAF fleets send out frequencies. They put frequencies into the overheads that can be quite disruptive for other trains, particularly the locos they use on the Caledonian sleepers. But we found a way around that. If we put the units with the pan up but in sleep mode, they don't seem to cause a problem. The other thing we need to be aware of is if there's any planned engineering work that might require an isolation in areas where we've also got trains stabled. And again, going back to January, we had an issue in Ilkley where we leave units, and there was a planned isolation, although in the end it got cancelled, so we got away with it. Other infrastructure issues, mechanical points in snow and ice are a problem, particularly where we've not got point seating. Point seating now there's a lot of intelligent infrastructure now, so it actually tells control if it's working. It's not fitted universally yet, and there are still some mechanical points without point heating. There's a set at Rainford Junction that are particularly problematic when it gets cold, so they require a lot of manual attention. As do there's a set in Liverpool. Just the names just dropped out at me. Anyway, well, there's a set in Liverpool of unheated ones on a pretty critical route that again requires a lot of attention. But fortunately, it's just outside the depot at Edge Hill. So that they tend to behave themselves. Other big issue is ice in tunnels. So the independent snow ploughs have got a breaker bar, so they can break icicles. But there was an incident in 2010 with a TPE 185 that was diverted down the Calder Valley, and a big block of ice had fallen on the track out of a ventilation shaft. It's quite interesting. At that time, I was involved with the debate about how we can safely inspect tunnels. Somebody suggested using a drone, and we all laughed, thinking they were back then they were nothing more than toys. But actually, look at drone technology now, and that could be a serious solution. So snow. What does the rule book say about snow? Normal running can take place unless you're told the snow is deeper than 8 inches above, or 200 mil above the railhead. If it's more than that 200 mil or 8 inches, you must suspend normal running of trains and tell operations control and wait for further instructions. Thankfully, those occasions don't happen that often. We had the beast from the east, which I think I've got a slide. There you are, the beast from the east. February and March 2018, you might recall it. I did a cab ride from Newcastle to Carlisle the week before. Spring was coming, everything was green. And a week later, we were digging a train out of a snowdrift on that route. It was amazing, particularly to be so late in the season. But what was interesting was the railway coped really well over the first few days, as particularly the road network started to close down. It was harder to get people out to deal with incidents, and train crews were struggling to get in. You know, the guys that drive or work the first trains of the day rely on being able to drive in, and were struggling to get in. We also had issues with engineering, trying to defrost sufficient trains to operate the service, because what we were finding was during the day they were out and about, things like doors were freezing up. So you think of going from A to B, chances are all the platforms on the same side of the track. So you're opening the same set of doors at every station, and the other set of doors are still shut. You get to B and start to come back to A, and you struggle to get those doors open. And it does beg a question about, are we as a network, as a railway, too dependent on road transport? If you think back to 50, 60 years ago, there were more people locally, and probably more trains used to transport people around. You might have read in the news that Northern are looking to procure up to 450 new multiple units. So these fleets, recognising climate change, these fleets will be specified to operate at up to 45 degrees. So that gives us quite a lot of climate change before we get into trouble with those. All these vehicles will have air conditioning in the saloons and cabs, but again, we'll have the same issue with the CAF fleet, because we've got this, you know, the Northern fleet tends to have doors at 1/3, 2/3 down the coach. They allow more people to get on and off because that's the nature of the passengers we use. Longer distance trains have the doors at the end of the coaches and usually have a separate door between the vestibules and the saloon, so they can control the temperature a lot better in hot weather. So it's a trade-off basically. Yeah, modern trains, again, our CAF fleet have already got heated couplers to prevent freezing. The light covers are heated, so they don't freeze over, and the internal water systems prevent freezing as well. So, or heating systems. Again, looking at the legacy fleet that don't have any of that, big problem when it gets really cold is burst pipes for the toilets and other water, the sinks and things. So it is a big issue. And again, that's one of the reasons we do the frost protection if it gets to -4 or below. So, and this is interesting because Storm Ao in January, you might remember it, we shut an awful lot of the network down. There was nothing north of Preston when the storm came, and then we gradually reopened. The Cumbrian coast and Windermere lines didn't reopen until Sunday, so they were effectively shut for 48 hours. Should the industry be more seasonally agnostic? But this can only be achieved with more resilient infrastructure, particularly vegetation. You know, winds bring trees down, and a flood site, you know where it's going to happen, and you can put something in place to alleviate it, but you just don't know where a tree is going to come down. Interestingly, we had an incident. There was a storm in December, Storm Dara. A tree blew down on the Leeds Northwest network, came down across the overheads. Perfectly healthy tree that was stood next to an ash tree that had been identified as suffering from ash dieback. So it's very difficult to predict in a high wind what is going to happen. The other thing, you know, what if we plan to shut the network ahead of a weather event that's either not as severe as forecast or doesn't even materialise? There was an incident on Anglia a few years ago where they withdrew, they put out or took out 50% of the service on the basis of a snow forecast, and the snow never materialised. So you've got that stakeholder issue if you withdraw a load of trains for something that doesn't happen. Polls of the public indicate that they believe that rail is the most resilient mode of transport in extreme weather. But the danger is we're at risk of losing that trust. And that's all my slides. If you've got another 10 minutes, I can do a quick autumn. just have a quick run through autumn. Just bear with me a minute. Stop sharing. I've got the other one open, so it shouldn't, by my ineptitude with IT, we should have it up and running fairly quickly. The main thing I wanted just to talk about autumn, managing low adhesion, there it is some of the stuff we're doing, some of the innovation projects. If I just skip down, I mean, that's interesting. Just if anybody thinks autumn's a new problem, that's an article from a railway magazine in 1836 that was reporting on the Manchester and Liverpool line. They were struggling up Whiston Bank, and they actually put two guys on the front of the locomotive with buckets of sand, throwing it on the track ahead of the locomotive. And if one of the paragraphs finishes with this, a remedy, however, I think would not be difficult to find. Well, almost 200 years later, we're still trying. So yeah, vegetation. I mean, the Salisbury incident in 2021, you look at what it used to look like and what it looks like now. That's repeated all around the network. So Network Rail use these vehicles to clean leaf contamination off the railhead in autumn. On the on my left hand side, yeah, we is an MPV, so that's a self-powered vehicle. And then we've also got the railhead treatment trains on the right. They basically do the same thing. They jet water at 1600 bar onto the railhead, and that's actually enough to cut through the rail if it was stationary. It's that high pressure. We also have things called traction gel applicators, so the line side cubicles that squirt out what they call a friction modifier. So it's a sandy gel, and then there's the guy on the ground with his rail scrubber. So yeah, over the years the paces were terrible in autumn. We've now got rid of them. You know, the 4 axles, so half the number of axles of a comparable train. No wheel slide prevention systems. That's a system that monitors wheel rotation and identifies if the train's sliding, releases the brakes, applies sand and reapplies them. So we replaced those with these new CAF trains. We've also retrofitted wheel slide prevention systems to the old fleets that are still in service. As a consequence, in 2018, we stopped 308 units during the course of that autumn with wheel flats, where trains had a slide and it gets a flat on the wheel. Last year we had 14, so there's been a massive reduction due to that. So double variable rate sanders, this is something we introduced this year. So traditionally units or trains on the network have one sander behind axle 3, so you leave the first 2 axles clear so you don't contaminate the rail too much or for activating track circuits. But what we've done with double variable rate sanders, we've fitted the fleets that operate out of Manchester to Crewe and Stoke-on-Trent and Hadfield line. Is put a second sander ahead of axle 7. And they also, as the name suggests, variable rate. They can drop a higher rate of sand at higher speed. So it not only does it spread the benefit down the train, but it increases the benefit of the sand at higher speed, and then it drops off as the train slows down. So first autumn 2024, these units have traditionally been very poor. We've had a number of incidents where they've slid through stations in autumn. They were involved with 19 of those incidents between 2020 and 2023. In 2024, we didn't have any of those incidents. So double variable rate sanders look as if they've got potential. We're looking at extending them to other fleets over the coming years. We've also been doing a trial with a system called WaterTrack. Now this works on the theory that the worst low adhesion occurs in damp and dewy conditions, and that adhesion actually improves as the railhead gets wetter. And speak to drivers, they'll say if it's lashing it down adhesion will improve. So all we're doing with this is we're jetting, we're not even jetting, we're spraying water onto the railhead every time we detect wheel slide prevention activity. So the train's slipping a bit and it throws a bit of water, it sprays a bit of water on the track at fairly low pressure. Now, there is a cleaning effect in that you soften the contamination with the water and it does break up in the wheels, but the primary aim is to reduce the actual amount of adhesion. So we're looking, again, we've fitted a fleet of trains in Yorkshire last year, and we're just evaluating the results from that to see whether that system is worth taking forward as well. And then the last one, just wanted to talk about, with the RHTTs, there are a number of disadvantages. It's a dedicated train. It's very, very expensive to run. We run them at night, and we lose treatment due to clashes with engineering possessions. We lose treatment due to equipment failures. So we're jetting at 1600 bar, puts a lot of stress on hoses and pumps. Most routes only get treated once a day, 6 days a week. Again, with all the possessions on a Sunday night, it makes it difficult to operate on the network, and also the vehicles need some maintenance. There's also some route restrictions which limit the use of modern locos. So the Wolds Coast again, we have to use class 37 locos on the RHTT, which are now 60 years or more old, and no sign of any kind of replacement. And the MPVs that we pictured earlier are obsolete. The Network Rail are looking at replacing those in CP8, and there's 32 of them. I don't think they'll get much change from £100 million. Oh, hang on, what's happening here? So we've been doing a scheme with Sheffield University for a number of years now, using dry ice, which is called cryogenic railhead cleaning. So you fire a jet of dry ice at the railhead, and you've got three things going on. You've got the kinetic energy of the dry ice particles hitting the railhead. You've got an immediate expansion into a gas and generation of heat. And those three things working together help clear contamination off the railhead at a much lower pressure. So this works at 10 bar. So basically, because it works at 10 bar, you need a lot less product, be it water or dry ice, than you do with the railhead treatment trains, which can often go out with 500,000 litres of water on board. So the idea with this is it can be a lot smaller. Now, we trialled it initially with a manually propelled trolley on a freight branch in Wakefield. It then moved up through a road railer, and that was on the West Highland line. We've tried it on a northern unit where the kit was fitted in the saloon, and we've run hoses out of windows to a jetting nozzle ahead of the wheels. Obviously, we could only do that at night use that at night in a possession. And that's some trial we did again on the freight branch near Wakefield. But the latest iteration, Sheffield have been out and bought themselves a couple of Pacers, bargain, £8,000 each, and they've fitted the equipment entirely underneath the unit, which is what we're looking to demonstrate. You can actually fit cleaning equipment to a passenger train. We've got some funding that's just come through. It's been a bit of a battle, but we're looking to trial them in the northeast, possibly the Bishop Auckland line this autumn, and hopefully we can prove that this system is effective. Now, this would take out a lot of the costs because it's a train that's running already. You don't have the issue with clashing with possessions. If you fit enough trains, you've got redundancy to cover any failures. And you potentially could clean lines of route several times a day, which would prevent the recontaminations. So, like I say, we've got big hopes of that this might be something we can do in the future. So there you are, quick run through autumn.
If anybody would like to ask a question before we wrap up the meeting, so please feel free to unmute your microphone and ask Rob, or put something in the chat box, and I'm sure Rob will do his best to answer them.
Or we might have something in the chat. Impressive how much hard work goes into preventing and dealing with this. Next time my train is delayed, I'm not going to judge it that harshly. Thanks. I can't quite read the.
Question was.
All right, go on.
So,
Fiona, sorry.
how many routes that Northern run services on are exclusively Northern, and you haven't got any other tox or pox to deal with? And all the decision making is basically yours. As compared
There are a few. I want to list
Oh, just percentage.
off the top of my head. I reckon about a quarter.
Right.
I was going to say something like the Cumbrian coast, but there's obviously freight goes down there, so that's not quite. But yeah, there's
Quite a few.
quite a few. Yeah.
Still have to liaise with Network Rail for the decisions on.
Oh yeah, because it's network rail infrastructure.
Yeah.
Even though it makes it easier in that it's a conversation between two parties. Where it gets complicated is where you've got multi-users and with different priorities.
Rob, I just have to smile when you were talking about the class 1 or 2 paces. As a PA designer over the years, they've really been the bane of our life in terms of gauging, and we keep getting told they're going, they've been
gone
off the network.
They've completely gone. We're just bringing them back again, just for a trial. But it was interesting that we couldn't use a northern train because we'd have to take it out of service for the whole autumn, and we haven't got that slack in the fleet to be able to do it. We could have gone to one of the leasing companies and hired a class 153 unit, but a lot of them are stood down at the moment, but they're quite expensive. So when we were offered a pacer for 8,000 or 2 pacers for £8,000, apparently we bought them off the Wensleydale Railway, and apparently when they took ownership of them, they came with full fuel tanks, and they reckon the fuel was worth more than the unit. But yeah, it was interesting because I had to go to this Network Rail panel, the Performance Innovation Fund, to get the funding for this trial last summer, and we have a director who sits on that panel, and his comment was, I've spent the last 5 years trying to get rid of pacers. Why are you bringing them back again? But it's literally a one-off, prove the concept, and then look at how we can then do feasibility studies to look at other fleet types.
Right.
Do you get complaints from track maintainers about sand?
Yes, and this is a big thing with the big concern about the double variable rate sanders. Because obviously, 2 standards. The RSSB did some trials in 2018 on a network rail test track using paper tape to simulate. You put paper tape down and wet it, and it simulates low adhesion. Now that trial suggested you got better braking, but you didn't use any more sand. Now what we found last autumn, and it's the same with South Western have got a system fitted to some of their fleets, is that there was an increase in sand use. Now, the routes we use the 323s on aren't particularly, or from a signalling perspective, activating trag circuits, they aren't particularly vulnerable. But if you start running through an area like Marple, which obviously we can't because it's not electrified, but if we roll it out onto other fleets, it's something that we need to bear in mind.
I don't particularly like all the bibs and the ballast drainage kind of getting.
Yeah, well, that's the other thing. Yeah. We'll just need to be aware of that.
I don't see any other questions in the chat box there, so if nobody else has got a question, I'd just like to say a big thank you to Rob on behalf of the Cheshire and North Wales PWI section for giving up his valuable spare time and giving us such an interesting talk. And it's nice to have a talk a little bit different than usual, and operations is a theme we don't get to hear about much. We tend to concentrate more on infrastructure and design and maintenance and construction, so it's been really good from that perspective.
Good.
Yeah, so thanks very much, Rob. So please feel free to give Rob a virtual hand clap if you're online, and we'll give him a round of applause.
Thank you.
That brings our meeting to